Welcome back to the Flipped Classroom. This is Mrs. Hill for today. Our topic today is called Rationalize the Denominator. Now, we've all seen something pretty similar when we discussed imaginary numbers. For example, if I left 2 divided by 3 plus I, we said that we cannot leave an imaginary number in the denominator, and our goal was to get rid of this imaginary number somehow. Can you think back to how we did that? Well, you've probably guessed it by now. We multiply what we call the conjugate. So the conjugate of 3 plus I is 3 minus I. And we multiplied both the top and the bottom by 3 minus I. So our goal today is to never leave a radical in the denominator. And we're going to call that rationalizing the denominator. Example number 1, 8 divided by radical 3. Now remember, we just said we never want to leave that radical in the denominator. So to rationalize it, I'm going to multiply the top and bottom by radical 3 itself. So I'm going to again write it on the bottom and the top. Now, when I actually multiply these together, I can't actually multiply the 8 and the 3. 8 is outside, 3 is inside. So when I write that, I'm just going to say it's 8 radical 3. However, on the bottom, the radical 3 is inside, and this 3 is inside, so I'm going to say that's really radical 9. And I'm going to go one step further to say that this is 8 radical 3 divided by the number 3, because of course the square root of 9 is the number 3. And I'm just going to ask myself, is this rationalized? And indeed it is. I don't have a radical in the denominator anymore. And then is this fraction simplified? Well, if I take a look at this 8 and this 3, there is nothing that goes evenly into both of them. So indeed I'm done. And my final answer is 8 radical 3 over 3. Let's try a similar problem. Number 2, 7 divided by radical 12. Now, I could take the time to break down radical 12 if I wanted to. But I'm just saying to myself, I need to rationalize the denominator. So again, to do that, I'm going to multiply both the top and bottom by radical 12. Again, the 7 is outside, the 12 is inside, so I can't actually multiply them together. I am just going to rewrite that as 7 radical 12. In the denominator, the 12 is inside and the 12 is inside, so I can multiply them and get radical 144. One last step is to simplify, of course. So I've got 7 radical 12 divided by, and the square root of 144, of course, is 12. Now, this fraction isn't completely simplified because I can break down radical 12. So I'm going to go ahead and practice what we did the other day. I'm going to say I can rewrite radical 12 as really the numbers 4 times 3. And again, I'm leaving them in the radical for the time being, because radical 4 times radical 3 is radical 12. Just a few quick steps left. I know the square root of 4 really is the number 2. So I've got a 7 times 2 times radical 3 all over 12. So I'm going to clean that up and say 7 times 2 is 14 radical 3 all over 12. Back to simplifying, I can say that 14 and 12 do have something in common. They are both divisible by the number 2. So my final answer is going to be 7 radical 3 divided by 6. And that is a completely rationalized and simplified fraction. Question 3. The square root of 4/6. Notice both the 4 and 6 are under the radical, and boy does that look ugly. But we can easily rewrite this in a simpler way. I just need to take the square root of 4 and 6. So I'm going to say this is equivalent to the square root of the numerator, which is 4, divided by the square root of the denominator, which is 6. Now this problem looks a lot more doable. So again, I just say to myself, I need to rationalize the denominator. So I'm going to multiply both the top and bottom by the square root of 6. The other thing I can pay attention to is I actually do know the square root of 4. So I'm going to rewrite this one more time as 2 radical 6. Now I'll multiply that top and bottom by radical 6 to rationalize the denominator. And as I continue to multiply, the 2 is outside, the 6 is inside, so I'm not really going to multiply them. I'm just going to write them next to each other. All over, 6 is inside and inside, so I'm going to say that's the square root of 36. Little more cleaning up, and I'll get 2 radical 6 all over. Of course, the square root of 36 is 6. And now I'm just going to check and see if my fraction is simplified. Well, I can simplify this 2 and 6 that are not in the radical, and 6 itself in this radical is fully simplified. There are no perfect squares there. So as I clean up, I'm going to say 2 goes in there once and into 6 3 times. So I end up with a final answer of radical 6 over 3. Hopefully at this point you're feeling a little more confident in our simplifying radicals here. Number 4. This time I have a monomial divided by a binomial. I have 2 terms on the bottom. So this is where that word conjugate comes back into play. Because there's 2 terms, I need to multiply by the conjugate. And you may want to go ahead and make a note for yourself there in your notebook. Multiply by the conjugate. So the conjugate of 1 minus radical 3 is 1 plus radical 3. And again, I'm going to do that to the top and bottom. Now to multiply these, I'm just going to take this 2 on top and distribute it to the 1 and to the radical 3. 2 times 1, of course, is just plain old 2. The 2 and the radical 3, well, the 2 is outside, the radical 3 is inside, so I'm just going to rewrite it as 2 radical 3. Now on the bottom, it's a little messier. I need to take my time and FOIL. Binomial times a binomial, of course, is FOIL. So first outer, inner, last, I'm going to get 1 plus radical 3 minus radical 3 minus radical 9. Just take your time and watch those signs. Make sure we have our positive and negatives in the correct order. Now, if you remember, when you multiplied a conjugate, the middle terms always canceled out. And you can see here that a positive radical 3 and a negative radical 3 do indeed cancel each other out. So I am just going to cross those out. The other thing I know right away is I do know that radical 9 turns into the number 3. So as I go to write my final answer, on top, these are not like terms. This does not have a radical 3. This does, so I cannot put them together. I've got 2 plus 2 radical 3 divided by, I have a 1 and a negative 3, which is going to get me a negative 2. One final piece to clean up here, you'll notice the outside terms that are not in the radical all have something in common. They are divisible by the number 2. And in fact, they're actually divisible by the number negative 2 as well. And I do want to make a note in my book here that I do not want to leave a negative in the denominator. Okay, so let's take a moment and write that down. We do not want to leave a negative in the denominator. So I'm going to divide every term by negative 2. So this number will become negative 1 minus 1 radical 3 divided by 1 as I divide each of these terms by negative 2. So my final answer will read negative 1 minus radical 3. Question number 5. 1 divided by 5 plus radical 6. If you're feeling brave enough, I would at this point pause me, try multiplying by the conjugate by yourself, see where it gets you, and then compare my answer at the end. So I'm going to multiply by 5 minus radical 6, and I'm going to do that again to the top and bottom, and that's called the conjugate. I'm going to take my time. I'm going to take this 1 and distribute it through. 1 happens to be an extremely nice number, so I get 5 minus radical 6 on top. On the bottom, I've got to take my time because it's that binomial times a binomial and FOIL. So I've got 25 minus 5 radical 6 plus 5 radical 6 minus the square root of 36. As I go through and clean that up, on top, I just have my 5 minus radical 6. On the bottom, again, this negative 5 radical 6, positive 5 radical 6 right here, they should cancel each other out when we multiply by that conjugate. And lastly, I know the square root of 36 is just the number 6. So I'm left with 25 minus 6, which will get me 19. And as I go and check to see if it needs to be simplified, there's a 5, a 1 here, and a 19, and they have nothing in common. So this will be my final answer. Number 6, radical 2 divided by 4 plus radical 5. Well, same idea as we've been doing here. Can't leave anything with a radical on the bottom, and because it's that binomial, we're multiplying by the conjugate. 4 minus radical 5. 4 minus radical 5. Again, go ahead and pause me, try it on your own, and see if we end up with the same answer. Take this radical 2 and distribute it to both terms. Now notice 2 is inside, 4 is outside. They do not go together. So that is just 4 radical 2. But on the next term, 2 is inside and 5 is inside, so I'm going to say that's minus radical 10. I will multiply them together when they're in the same positions. All over 16 minus 4 radical 5 plus 4 radical 5 minus radical 25. Continuing, we've got 4 radical 2 minus radical 10. All over, those conjugates should cancel out if I multiplied correctly, and the square root of 25 turns into just the number 5. 16 minus 5 should get me over 11. Now, a couple things to pay attention to. The 4, the 1, and the 11 have nothing in common. Radical 2 and radical 10 are not like terms, so we can't put them together. And 2 and 10 are simplified. So in this case, we are completely simplified and rationalized. Well, folks, we're cooking. We are doing a great job, and I hope you're feeling pretty confident. I think we'll give 2 more questions a whirl here. Number 7, radical 3 plus 1 divided by radical 3 minus 2. Again, go ahead and pause me, try it on your own, and see how well you do. Radical 3 plus 2 would be the conjugate. Radical 3 plus 2. Carefully take your time and FOIL. So I've got, radical 9 plus 2 radical 3 plus radical 3 plus 3. Radical 9 plus 2 radical 3 minus 2 radical 3 minus 4. Let's see, I do have like terms. These 2 radicals, 2 radical 3 plus 1 radical 3 should get me 3 radical 3. Oopsie. Okay, I'm back, haven't quite figured that out. 2 radical 3 plus radical 3 should get me 3 radical 3. Radical 9, of course, is the number 3, and 3 plus 2 should be 5. So on top, I would say I have 5 plus 3 radical 3. On the bottom, I've got my conjugates again, which cancel each other out. And I should know the square root of 9 is the number 3. And 3 minus 4 should be negative 1. Now, I'm almost done at this point. Just 2 simple things left. 1, I don't want to leave that negative on the bottom, so I am going to divide every term by negative 1. So I end up with negative 5 minus 3 radical 3. And lastly, I just want to double check, is my radical simplified? And it is, so we are good to go. Well, folks, it's just about that time. We have made it to our last example. Again, I encourage you to try it on your own and compare with me in the end. So here goes nothing. 3 plus radical 5 for my conjugate, 3 plus radical 5. Remember, binomial times binomial means to FOIL. I've got my top and bottom FOILed out. So as I clean this up, I'm going to say, together these like terms and I know they're like terms because they both have radical 5, make a 7 radical 5. I know this last term is going to turn into a 5, so 12 plus 5 should get me 17. My conjugates in the bottom should cancel, and this radical 5 will turn into a 5, and 9 minus 5 should be 4. Last quick check. No like terms on the outside here, can't break radical 5 down, so I would say we are good to go. Have yourself a great evening, come prepared with some good questions for tomorrow, and we look forward to seeing you in class.